Hey guys, it's Miss Spangler. I'm reporting live from my apartment right now. Trying out this whole screencast thing. I'm only going to be with you for a minute in the corner here, and then I'm going to be showing you a video I recorded on the document camera, and I'm going to be talking over it. So if I'm talking over it and it's already been recorded, it might be a little off. But again, the goal was not to be on the whiteboard. So we'll see how this goes. If this doesn't go well and you don't understand what I'm doing on the notes, you can check out the two videos I posted on my haiku page, which pretty much say the same thing, but I wanted to be able to talk to you myself. So here goes. I'm going away now and I'm just going to be talking over the notes. All right, so we're talking about inverse functions today. This is 6.4, which comes right after what we did yesterday, which was a lot of compositions. Trying to hopefully my hand gets out of the way. Inverse functions, when I say that, and I'm going to pause this just for a second. When I say inverse, I'm hoping that you are thinking of inverse operations, or maybe now that I say that, that sounds familiar to you. Inverse means the opposite, and inverse operations are things like addition and subtraction and multiplication and division, things that undo each other. So that's what inverse functions are. They are functions that undo each other. So to kind of give you an example of that before I get into it, I want to kind of review what we did yesterday. So I'm going to give you two functions, an fx, which will be the cubed root of x plus 1, and I'll give you gx will be x minus 1 cubed. And our goal is going to be to find, and now that I'm watching this, I'm realizing that this is wrong. I wrote the f and the g switched. So we're going to be finding the composition of g and f, but the g should be on the outside, okay? Otherwise this is going to make a little less sense. Okay, so assuming the g is on the outside, we're going to start by finding f of 8. So if I took 8 and plugged it into my function f, that's what I'm doing right now. I'd have the cubed root of 8 plus 1. Cubed root of 8 is 2. 2 plus 1 is 3. So if I plug in 8 to f, I get 3. I've just evaluated function f for 8 and gotten 3. So then if I'm doing a composition, which is what we learned yesterday, you would then take the number you got and then plug it into your other function. So that's what I'm about to do. I'm going to plug in 3 to g and see what I get. So here I am plugging in 3. So I'm going to have 3 minus 1 cubed, because that's function g. Which makes 2 cubed. And 2 cubed is 8. So I'm hoping that now you see that I've just gotten the same number that I started with. I started with 8, plugged into f. I got 3, then I took that and I plugged it into g, and it just gave me 8 again. I got back to where I started. So what happened here was that function g undid function f. So that makes g the inverse of f. Inverse functions, they undo each other. Okay, so then I can now take my original f. So I'm going to rewrite it. F of x is the cubed root of x plus 1. And I can say that, and now I'm going to write a little symbol that isn't going to make sense to you. What I just wrote, f to the negative 1 x, that stands for inverse of x. So I just replaced g with inverse of x. That's what this means right here, the inverse of x. That is how you would write the inverse of f of x. Okay, now keep in mind they're inverses because when I plug one thing into the other and then plug what I get into the other one, it undoes the inverse. That's what makes it an inverse. Now, be really careful when you see this. I know when you see this it looks like an exponent, but it's not. It's not an exponent. It has a little -1 next to it. That's just how we write inverse. It does not mean exponent of -1. So you're not going to put 1 over x minus 1 cubed. Do not do that. Just think of it as inverse. Okay, I wanted to talk about that just so you get what an inverse does and why it's called an inverse. So now let's talk about what you're really going to be doing today, which is how to find inverses. So it just so happened, and I'm going to pause again, just so happened that g and f up there, the ones that I gave you, were inverses of each other. But most functions aren't inverses of each other. Most functions are just functions. So if you want to find the one function that is going to make this little cycle up here, you have to do something specific, and that's what I'm about to tell you, how to find the inverse of a function. Okay, step 1. We don't want to use f of x, so we're going to replace the f of x that usually confuses you guys with a y. Okay, so take your fx, replace it with a y, so you feel more comfortable and so things make more sense. Step 2, you are going to switch your I'm sorry, we already replaced f of x. We're going to switch the x and the y. So your equation has an x somewhere and has a y somewhere. You're just going to take them and switch places. Pretty simple. Once you do that, you're going to solve for y. So probably your equation was already solved for y, but then when you switched it with the x, now it's solved for x. So now you got to do all your operations and get the new y by itself. Once you do that, you're going to just replace the y with f inverse of x, just to go back to the fx form. Okay, I'll show you what I mean in this next example. Okay, example 1. We're going to find the inverse of f of x equals -4x plus 16. This is a pretty simple one. We'll start simple. Okay, so again, step 1, replace the f of x with y. We don't want to use fx, so we're going to just make it a y, because remember, y and fx, they mean the same. Okay, next step, we're going to switch the x and the y. So that y is going to become an x, and that x is going to become a y. So now we get to a point where the y is not by itself anymore, so we want to get it back to that form so that y is by itself again. So the first step there would be to subtract 16 on both sides. Okay, so then that means my next step, now that I got rid of the 16, is to divide by -4. We know this. Which gives me x minus 16 over -4 is equal to y. And I'm just going to rewrite that. So the next step, replace the y with the inverse of x. That's what that means. Again, inverse. So the inverse of fx is x minus 16 over -4. And I could rewrite that because you could divide them both by -4. -1/4 x plus 4. They mean the same thing, so either one would be correct on the tests. Again, this could be a y, but we're writing it like this so that we're saying, oh, that's the inverse of fx. So make sure you do replace the y in the end with the inverse, because that's what you've done. You found the inverse. All right, let's do another one. This will be slightly harder because they won't always be linear equations like that. Okay, find the inverse if f of x is, we'll do the cubed root of x plus 3. All right, first step, we're replacing the fx with the y. Not changing anything else yet, we just don't want fx, we're just going to make it y. Next step, move the paper up. And after that, we're going to switch the x and the y. Pretty simple. Just switch places. Okay, this one's a little harder to get by itself. So the next step should be to get y by itself, but y is stuck under a radical. So you probably know that to get rid of a square root, you're supposed to square both sides. So it makes sense that if you want to get rid of a cubed root, we're going to cube both sides. So I'm going to raise both sides of the equation to the third power. That cancels out the cubed root. If it were a fourth root, you'd raise it to the fourth power. If it were a fifth root, you'd raise it to the fifth power. You get what I'm saying? Okay, so that gives us x cubed equals y plus 3, which means we just have to subtract 3. And we've got x cubed minus 3 equals y. So again, I'm going to just rewrite that so that it says the inverse of f, is x cubed minus 3. Those are inverse functions. They would undo each other. Okay, that was a really brief introduction to inverses. There's a couple more examples. I gave you 2 videos. One of them is pretty long. It talks about kind of what I talked about at the beginning, but also it goes on to the graphs of inverses, which I didn't really want to get into in a long video. So feel free to watch more of that. But this is the basics of what you're doing today. Is you're going to be switching x and y and solving for y, which is really pretty simple because it's basically just algebra 1. It's just make sure that you replace the fx and then switch. A lot of people replace the fx and think that they've already switched. Make sure you switch them both, and then you're solving for y. So it's just a matter of doing the correct operations. All right, good luck. Your book has a lot of good examples too. I kept this one short, so you should have a lot of time to work on homework, and I will see you tomorrow when we will review and then take a quick quiz. All right, good luck.